Hello, Mr. Sutton here, bringing you the Pre-Cal Honors 8-3 Extra Practice Number 1 solutions on infinite geometric series. On this problem, we're trying to figure out convergence and the sum of this infinite series. So, first thing we notice is that we are multiplying by something each time, the same thing each time, to get the next term. So this is a geometric series, and an infinite one at that. We have an a1 value, a first term of 1. The common ratio, we're multiplying each time by 2/3, so that's the r value. 2/3 divided by 1 if you really wanted to be technical about it. So that's 2/3. And now the really important thing here is that the absolute value of that, which is also 2/3, is a number that is less than 1, which means that this series is going to converge, and we can go ahead and figure out its sum. So that formula, a1 over 1 minus r for the sum of an infinite geometric series. So that's going to be 1 over 1 minus 2/3. That's going to be 1 over 1/3, which if we do same change flip, that's going to just be 3. For this problem, first we want to figure out if this converges or diverges. Important thing to note here is that this is a geometric series. We're multiplying by the same thing each time to get all the next terms. We have a first term of 2. That might be important later on. For the common ratio, the r value, we just take any of these and divide it by the term before it. So for example, negative 1 over 2 is actually going to be the common ratio. Now the crucial thing here is that the absolute value of that, which is positive 1/2, is a number less than 1, which means that this series does in fact converge. So we can go ahead and figure out the sum. The formula for that, we're going to have s equals a1 over 1 minus r. So that's going to be 2 over 1 minus negative 1/2, so 1 plus 1/2. So that's going to be 2 over 3/2. And then if we multiply by the reciprocal, we're really doing 2 times 2 over 3, which is going to be 4/3. On this problem, we have to figure out whether this series converges or not, and if it does converge, what its sum is. So first off, we notice that this is a geometric series. We're multiplying by the same thing over and over again to get each subsequent term. So since this is geometric, we have a first term we might want to identify, which is 3 in this case. That's going to be our a1 value for later on. And we also want to figure out the common ratio, the r value. Now to get this, you just have to take any of these terms and divide it by the term right before it. So negative 0.3 divided by 3, for example, would give you the r value. Now if you're not really sure how to reduce this, a little trick you can use, you can multiply the numerator and denominator by 10. So that would actually give you negative 3 over 30, which you could then reduce to negative 1 over 10. The absolute value of negative 1/10, positive 1/10, is less than 1, which tells us that this series is slowing down. It's going to converge to a single sum, which means we can actually go ahead and find the sum. So our formula for that, again, that's going to be s equals a1 over 1 minus r. And let's see, we have an a1 value of 3, so that's 3 over 1 minus negative 1/10. So this is 3 over 1 plus 1/10, which is going to be 11/10 downstairs. Multiplying by the reciprocal, we have 3 times 10 over 11, which is going to be 30 over 11. For this one, we want to know if the series converges or not and what the sum of it is. First thing to notice is that we appear to be multiplying by the same thing over and over again. So this is a geometric series. A1 value is going to be 160. For the r value, what we're multiplying by each time, just take any of these terms and divide it by the term right before it. So for example, 80 divided by 160, you can reduce that to 1/2. And just double check, and it looks like we are multiplying by 1/2 each time we get to another term. The absolute value of that is less than 1. This tells us that the series is converging, and we can find its sum. The sum is going to be a1 over 1 minus r. a1 in this case, again, that was 160. 1 minus r, we're really doing 1 minus 1/2. So this is 160 over 1/2. Which, same change flip, you're really doing 160 times 2 over 1, or 320. For this problem, to figure out if this converges or not, and what the sum is, First, we need to recognize that this is a geometric series. We are multiplying by the same thing over and over again. We have an a1 value, a first term of 4. And for the r value, the common ratio, just take any of these terms and divide it by the one before it. So for example, 4/3 divided by 4, well, that's really 4/3 times 1/4. 4's cancel, you really just got 1/3. Absolute value of that is less than 1, which is telling us that this series is going to converge, so we can actually figure out the sum. So that's a1 over 1 minus r, which is going to be 4 over 1 minus 1/3. So that's 4 over 2/3, which if I same change flip that, I'm really doing 4 times 3 over 2. 4 and 2 cancel to give me a 2 here, so we're really doing 2 times 3, which comes out to 6. For this problem, we want to know if this series converges or diverges, and if it does converge, what its sum might be. So the key on this one is recognizing that we're dealing with a geometric series, and we know this because we're multiplying by the same thing over and over again. To get the next term, you keep multiplying by e over pi because of this variable in the exponent. So we need the a1 value and the r value out of this. For a1, that's what I get when I plug in the first n value, which is 1 in this case, for the n here. So that's just going to be e over pi. For the r value, that's what we keep multiplying by. That's the thing that's being raised to the nth power, which is also e over pi. These two things aren't always the same, but this time they were. So e over pi, is that greater than 1 or less than 1? Well, e is about 2.7 and some change. Pi is about 3.14. E is less than pi, so if I divide a number by something bigger than itself, I'm getting something less than 1. So since the absolute value of this is less than 1, that is telling us that this is a converging series, and we can figure out the sum. The sum, we're going to use that formula, S equals a1 over 1 minus r. For a1, we've got e over pi. For r, we've also got e over pi. So this is kind of a big mess. We're going to go ahead and take the trouble to simplify this. So first, let me start by combining the terms in the big denominator here. I need to get a common denominator, so I can treat this 1 as a pi over pi. Subtracting then, I have pi minus e rather over pi in that denominator. And now I can multiply by the reciprocal, so I've got e over pi times, flipping this bottom one, pi over pi minus e. At this point, I notice that these two pi's are canceling, so I just end up with e over pi minus e for my final simplified answer. For this problem, we want to know if this series in sigma notation converges or diverges, and if it does converge, what it all adds up to. So taking a look at this, we notice that this is a geometric series. Since we have this nth power here, that's telling us that we're multiplying by the same thing over and over again. And I could figure out the first term of this series, but let me just go straight to finding that common ratio. That is going to be this 5/4 that's got this variable in the exponent. Now, the key thing here is that 5 over 4, absolute value of that, is bigger than 1, bigger than or equal to 1. So that is telling us that this series actually diverges. It just keeps growing without bound, which means that we can't find its sum, so we are done with this one. For this problem, we're given the sum of a series and its first term, and we want to figure out the common ratio, given that this is an infinite geometric series. So we're going to use our infinite sum formula and just see what this comes out to. So I've got S equals a1 over 1 minus r. And now let's see, for S here I can plug in 5/8. For a1, that's going to be 1/2, so we have 1/2 over 1 minus r. Let me just solve for r now. I can do that by cross multiplying. So I've got 5 times 1 minus r, that's 5 minus 5r. And then 8 times 1/2 is going to be 4. Subtracting 5, that's going to be a -1 over there. Dividing by -5, we have an r value of 1/5. For this problem, we want to figure out an r value such that the sum from 1 to infinity of 2r to the n minus 1 converges to 5. Now the key on this one is that we have an infinite series. And not just any series, this is an infinite geometric series. We have this r being raised, this constant being raised to a variable, so we're multiplying by the same thing over and over again. Since this is an infinite geometric series, we can use the sum formula, s equals a1 over 1 minus r, and we're essentially solving for r. That means we need to figure out some values for s and a1. Now s, they already kind of gave us. They said this whole thing should converge to 5. Well, that means that 5 is the sum, so we can write 5 for big S. Now for a1, that's the first term. That's whatever you get when you plug in the first n value for n here. If we do that, we're going to have 2 times r to the 0. Well, r to the 0 is just 1, so that leaves the 2 here. 2 times 1 is just 2, so we have an a1 value of 2 over 1 minus r. And now multiplying both sides by 1 minus r, that's going to be 5 minus 5r. Subtracting 5 from both sides, we've got negative 3 over there. So divide by negative 5, that's going to be positive 3/5. On this problem, we're told that s sub n is the nth partial sum of this infinite series with n value greater than 3. And we want to know which of the following here is true. So taking a look at all these answer choices, these are all talking about a sub n. A sub n is the nth term. So they're basically trying to relate a sub n, the nth term, to these different partial sums. So we've got the partial sum of the n minus 1th term minus the partial sum of the n minus 2th term, and a whole bunch of other ones here. So how can we sort all this out? Well, the key relationship we have to keep in mind is that the nth partial sum, s sub n, to get this, you would need to know the sum of all the terms before the nth term. That's s sub n minus 1. So this is everything added up until you get to that nth term. And then to get the nth partial sum, you have to take this and add the nth term, a sub n. Rearranging this, we can then write a sub n is just going to be s sub n minus s sub n minus 1. Or to put it another way, the nth term is just the sum of all the items minus the sum of everything except that nth term. So that ends up being answer choice B. For this problem, we're told a is a non-zero real number and r is a real number, such that r is between 0 and 1, which is basically telling us here that these series are both going to converge to some kind of real number. So we want to know the value of this series from 0 to infinity minus essentially the same series but from 1 to infinity instead. So one way to very quickly reason about this is that we're taking this series and then we're subtracting essentially the same exact series, all the terms except the very first term, the term where n equals 0. So if you take pretty much everything and subtract everything except for that one thing in the beginning, you're just going to get the thing in the beginning. Now, if you want to do this a little bit more rigorously or explained out here, another way we could do this is to start writing out each of these series. So this first series, just starting with n equals 0, that's going to give us an a value of a series term of just a, because you've got a times r to the 0, which is just a. And then if n equals 1, you've got a times r, and we don't know what a and r are, but it's not really going to matter for this. And then we've got n equals 2, so this is plus ar squared, and we could keep going with this. But now let's turn our attention to all this stuff that we're subtracting. So over here, we've got a times r to the 1. That's the very first thing we're plugging in. So that's just ar. And then we have a times r to the 2. And that's being added inside this big parentheses, because again, it's essentially the same series as we had here, but without this a in the beginning. Now, we can see that if we take all of these terms and subtract all of these terms, we have a positive ar, we have a negative ar. Those are going to cancel. We have a positive ar squared, we have a negative ar squared. Those are going to cancel. And everything after ar squared that we're not writing down is going to cancel out with everything after this ar squared. So the only thing that's left when all this canceling happens is this very first term, a, that doesn't have a kind of an evil counterpart in this parentheses over here. So this all just comes out to a, which ends up being choice B.